This video is for the inverses of linear functions. So we are going to find the inverses using, flip this, an equation, a table, and a graph. Okay. So from an equation, to write the inverse, we're going to replace f of x with a y, and then we're going to switch the x and the y. So we would have y equals x plus 5, and then we're going to swap those two letters. X equals y plus 5. Then we're going to solve for y, so we want to get everything away from y. So we would subtract the 5 from both sides. Okay, so we got y by itself. And then we're going to replace the y with f to the negative 1 of x equals x minus 5. So I flipped the whole equation itself. So this is the representation, the symbol for it being an inverse of something. Okay. So now we have 2x minus 3. So we're going to replace the f of x with a y, and then we're going to flip. So it would be x equals 2y minus 3. So when we flip, we literally just take the x and stick it in the y spot, take the y, stick it in the x spot. All right, so if we solve for y here, we're going to add 3 to both sides, and then we're going to divide by 2. So we would have x plus 3 divided by 2. And then swap out that y with f to the negative 1 equals x plus 3 over 2. You could also write that as like 1/2 x plus 3 over 2, but I wanted to write it that way just so you can see that this is still a linear. So the inverse of a linear function is still a linear function. Okay? All right, so from a table, if they give you a table of values, you can swap the x and the y values to create a table for your inverse. So what happens in an inverse is the x's become your y values. And then your y values become your x's. So all you're doing really is swapping these labels out. So the inverse of a linear function is another linear function. And so to find the equation for that table, we can use linear regression. So put an x there, y there, and then we've got 5, 7, 9, 11, 13, and 15. Then we've got 0, 1, 2, 3, 4, and 5. And then menu, 4, 1, and 6. Change the x list to x, the y list to y. And then there's our pieces that we need. You could also use the finite differences, what we started the year off with. So f to the negative 1x equals, so my slope is 0.5 or 1/2 x, and then negative 2.5 as a fraction is 5 over 2. You could also write it, so going from this to this, we could write this as x minus 5 over 2. Excuse me. All right, and finally from a graph. All right, so the first thing it says is write a function to represent the graph to the right. So my y-intercept is a negative 8, and then if I find another good point here to do the slope, I can see that my slope, I'm going down 1 over 2. So that's my slope. Negative 1 over 2, and then we said y-intercept was a negative 8. So the function for that graph that's already there is a negative 1/2 x minus 8. So we can graph the inverse of the function above on the same coordinate plane. How we do that is we just switch the points. So if the y-intercept is 0, negative 8, that means my inverse is going to have a point at negative 8, comma 0. So you flip the values, negative 8 comma 0. The other point that we picked for our slope was negative, or 2 comma negative 9. So if we flip it, that would be negative 9 and a positive 2. Okay, and then we can just draw a line through it. For a linear, all we need are 2 points. And so what happens here with these graphs? The graph of the inverse of the function will be reflected over the line y equals x. So the line y equals x is 1, 1, 2, 2, 3, 3. So it's just your basic, it's your parent function points. And so I'm going to kind of graph this in where you can see it. So you can see how it's a reflection. If I fold it along that dashed line, everything would line up perfectly. So if I want to write a symbolic representation, I can use those points. So our points that we used for the inverse was that. I can use those points to write a function for it. So again, I can use linear regression. As long as I have 2 points for a linear, I can use linear regression. So negative 8, negative 9, 0 and 2, min u 4, 1, 6, x list is x, y list is y. Oh, I do have enough. Min u 4, 1, oh, 3. I'm sorry, I was trying to do quadratic. Try that again. And so there's the information that I need. So f of negative 1x equals negative 2x minus 16.